Welcome back to the deep dive. Okay, if you're working in security, maybe critical infrastructure, or really any sector that's heavily regulated, ransomware, it's the nightmare scenario. But today, we're looking at something different. A platform making a pretty bold promise, enterprise-level defense that actually works everywhere, all the time. We are diving deep into RansomEye. It's pitched as a unified ransomware defense platform, and our mission really is to unpack this security stack. It claims it can consolidate pretty much everything: detection, correlation, containment, forensics, summarization, response, and learning. We need to see if it can really unify all of that without dropping the ball on performance or, crucially, control.
It's a massive claim, no doubt. But the thing that makes RansomEye stand out, like right from the get-go, is its resilience model. It's designed to run with, and this is key, full feature parity, both online, and this is the kicker, in completely air-gapped, fully offline modes, which means zero cloud dependency, none. Not for its AI, not for its LLM capabilities.
Okay, so that's immediately the pivot point for this whole discussion, isn't it? For you listening, especially if you need the quick takeaway, running advanced AI, running large language models locally, that takes serious horsepower. How do they actually guarantee that full functionality, especially the really smart stuff like incident summarization, when it's totally cut off, behind that thick governance wall?
Well, they tackle that by fundamentally changing how they deploy the machine learning side. They're not just calling cloud APIs like everyone else. They bring the entire intelligence stack right onto the premises. So
Right.
RansomEye uses actual trained AI models, think standard.pkl files, and importantly, a local large language model, a local LLM. And instead of some lockdown proprietary format, they're using optimized standard things like GGUF files for the LLM.
Okay.
These are built for running efficiently on local CPUs, maybe GPUs, just on standard appliance hardware. That's the trick. That's how they get the AI engine and the LLM helping analysts without ever needing that internet connection.
Right. And here's where, for me at least, the compliance and audit angle gets really interesting. This feels like the genuine aha moment in the material we looked at. The platform guarantees SHAP explainability across all model inferences. Explainability often gets, fuzzy when you deploy AI, doesn't it? Especially under pressure. So why is having guaranteed SAP not just a nice tech feature, but maybe a strategic necessity here?
Yeah, security has always had this black box issue, right? The firewall blocks, the EDR screams, high severity. But the analyst is left wondering, okay, why exactly? What's the specific reason? SHAP, that's Shapley Additive Explanations, it kind of cracks that open. Think of it like a judge explaining the reasoning behind a verdict, not just handing down the sentence. SHAP gives you that specific weighted breakdown. If the AI gives an event a score of, say, 98 out of 100, SHAP tells you why. It might say, okay, this specific process chain, that contributed 60% to the score. The weird network entropy spike added 30%, and trying to touch that canary file, that was the other 10%.
Oh, we see.
This massively cleans up the evidence trail for forensics. And just practically speaking, it lets analysts tune their response playbooks with amazing precision. You could really slash those false positive rates.
That makes a ton of sense, because in critical sectors, if you can't audit the automation, you simply can't deploy it. Full stop. Okay, speaking of audits, once an incident is buttoned up, how does that local intelligence, summarize potentially gigabytes of messy data into something an exec can actually read?
That falls to the LLM behavior summarizer. And it's not just parsing raw logs. It digests the structured output from the correlation engine, the incident graphs, the MITRE mappings we'll get to, the forensic artifacts, and it generates complete narratives.
All locally.
All locally. Because the LLM is right there, air gap safe, it can generate these reports, maybe different versions for the SOC team, for executives, even for legal pretty much instantly. And critically, it includes citations, little pointers back to the original signed source artifacts.
Okay, that's huge for evidence.
Absolutely indispensable for their target audience. Think government, defense, space systems, critical infrastructure, places where response time is everything, connectivity might be zero, and the governance hammer demands immutable, cited proof now.
All right, let's walk through the architecture then. The promise is unification, the single stack idea. How does RansomEye actually gather the data efficiently? And how does it turn what could be just a mess of scattered alerts into a coherent, actionable incident? All while staying, resilient. It looks like it starts right at the edges with data collection. You've got Linux and Windows agents and this DPI probe. Let's start with those agents. You mentioned they run rootless by default, grabbing syscall and registry data. What's the strategic thinking behind running rootless in these high security zones?
Running rootless isn't just like a technical detail. It's basic security hygiene, really. If an attacker somehow compromises that agent, their ability to move laterally or do serious damage is way more limited because the agent itself doesn't have admin rights.
Right, limits the blast radius.
Exactly. And in places with strict OT-IT divides, that's vital for maintaining that segmentation. You don't want an IT agent compromised jumping over to the OT side. So data from those agents, plus the deep packet inspection from the DPI probe, which is looking for really specific things like JA3, JA3S fingerprints, SNI details, entropy spikes in traffic, all that gets fed into the alert engine.
Okay, and that alert engine applies these YAML policies you mentioned, deduplicating, scoring the data. You also talked about resilience earlier.
Yeah.
How is that baked into this first stage?
Well, because the whole platform is built, assuming it might be offline, resilience has to be job one. They use persistent disk-backed queues right there in the alert engine.
Ah, okay.
So if the main database has a wobble, or maybe the correlation engine downstream gets temporarily overloaded, the raw, scored alerts. They're safely written to disk. They sit in a queue waiting to be processed when things are back online.
Yeah.
You never lose that initial detection signal. It's buffered.
That's just solid operational design. Okay, so once it's scored, the data moves to the threat correlation engine. This sounds like where the real heavy lifting happens, turning scattered signals into a story.
Absolutely. This is where it gets clever.
Mm-hmm.
The correlation engine takes all those separate alerts, maybe a registry change on host A, a network spike from IPB, a weird process started by user C,
Yeah.
and links them together into a single incident graph based on shared things like the host, the user, the IP, the process. The output is this really critical file, often called correlatedtimeline.json.
Yeah.
And that structured timeline immediately feeds the next stage.
Which is the kill chain core.
Right. The kill chain core takes that correlated graph and maps it directly onto the INRE, ATT, and CK framework, tactics and techniques.
So it's not just saying something bad happened. It's saying, here's where the attacker likely is in their attack life cycle. That helps the analysts prioritize, maybe spot gaps in their defenses too.
Precisely. It provides that crucial context. Are they still trying to get in? Are they moving laterally? Are they starting to exfiltrate data? That changes your response priorities.
And underpinning all this, you need stability, right? Especially if you can't just easily reboot things.
Definitely.
Yep.
For operational reliability, especially in environments where hands-on fixes are difficult or restricted, they've built it to be pretty self-sufficient. All the different parts run as standard system services, and they have integrated watchdogs keeping an eye on them.
Okay, standard Linux stuff.
Yeah, well-proven stuff. And they've tried to simplify the back end, too. Configuration is mainly through standardized env-only variables, makes deployment and automation much cleaner, less prone to typos. And the core database, it's just PostgreSQL, a reliable workhorse. They use monthly partitioning to manage the huge data volumes needed for, say, 7 years of retention without performance grinding to a halt. Rootless services by default, PostgreSQL-only, env vars. It's all about robust simplicity.
Okay, let's shift gears a bit. We've detected and correlated an incident, it's explained. But the attacker might still be active, so the next steps are critical. Deep forensics and shutting it down fast.
Right. That's where the forensic dump engine, DFIR, comes in. It's designed to be pretty comprehensive and kicks in automatically based on the incident severity or playbooks. It does deep captures memory dumps, process details, file system artifacts. It runs automated indicator of compromise extraction using YAML rules, regex patterns, whatever you've configured. And it manages the quarantine workflows.
And the legal side, chain of custody.
Huge focus there. Every single artifact that collects is hashed. Every action taken by the system is logged as an immutable audit entry. Can't be changed. The idea is that the evidence is packaged up automatically, ready to hand over to legal teams or external investigators with that chain of custody completely intact.
Okay, now I'm curious about the proactive bit you mentioned earlier, the deception framework. Things like honeypots and canary files can sometimes be, well, noisy. How does RansomEye stop the bait from just creating more alert fatigue for the SOC?
That's a really fair question. Noise is the enemy of effective security monitoring, right? Their approach seems to be integrating the deception deeply. It's not just standalone honeypots. They talk about native canary files dropped onto systems, honey credentials injected into memory, fake network shares, even decoy registry keys.
Native integration.
Yeah, and because these are synthetic, specifically crafted things that no legitimate user or process should ever touch, any interaction is almost certainly malicious. High signal, very low noise. So when a decoy gets tripped, someone reads the canary file, tries to use the honey credential, that alert goes straight to the alert engine. And here's the smart part. The classification of that trigger immediately comes with the SHAP rationale.
Ah, the explainability again.
Exactly. You don't need an analyst debating, is this real or just noise? The system says high-confidence malicious activity because this specific decoy credential was accessed by this process, contributing 99% to the score. It instantly confirms the finding and pushes it up a priority list for response.
So the system uses its own intelligence to confirm the malicious intent from the deception.
Okay, makes sense. Now we need to actually stop the attack. That's the incident response and remediation module.
Correct. Containment actions are defined in standard YAML playbooks. Things like, isolating a host from the network, killing a specific malicious process, pushing out firewall blocks. Pretty standard response actions.
But is it just manual selection?
No, this is where the AI comes back in. There's an AI ranker that looks at the correlated incident timeline, the emitter mapping, the SHAP rationale from the detection, and it actually recommends or even automatically selects the most appropriate playbook.
So it suggests the best course of action.
Yeah, or executes it, depending on your policy. You can run it in human-in-the-loop mode, where an analyst has to approve the action, or in full auto mode for speed. And critically, everything it does has full rollback tracking. If an automated action accidentally isolates the wrong machine or kills a critical process, you can undo it quickly and cleanly. That's essential for confidence in automation. And then there's one last piece, a sobering one. The decryptor engine. Sounds like planning for the worst has already happened.
It is. It's the final safety net if containment fails and ransomware actually deploys and encrypts files. It's designed first to classify the ransom node, figure out which ransomware family you're dealing with, which is vital for knowing if public decryptors exist or what recovery might look like. It also offers some offline heuristics, ways to potentially hunt for keys locally without connecting to anything.
And safety checks. You wouldn't want a decryptor causing more damage.
Exactly. It includes safety checks before attempting any decryption. And importantly, it keeps a secure ledger of every single decryption attempt, what was tried, on which files, whether it worked. This all feeds back into that final DFIR evidence bundle. It really tries to cover the whole life cycle, from the very first alert to the final recovery step. So the outcomes they're claiming are pretty bold. They're saying this automated correlation, the AI-ranked playbooks, it's expected to cut mean time to detect MTTD by something like 40 to 60%, and mean time to respond MTTR by 30 to 60%. These aren't small numbers.
That is a huge operational claim. If you peel that back a layer, the engine driving that speed, it isn't just the AI itself, it's the fact that it's all happening locally, right? No cloud latency.
Precisely. That's a major factor. Think about it. If every detection alert needs to go up to the cloud for scoring, if every correlation needs cloud compute, if the LLM summarization relies on a cloud API, you're adding network latency at every single step.
The seconds add up.
Seconds add up, especially in a firefight. By doing the detection, the correlation, the summarization, the playbook selection, all of it right there on the local appliance, they shave off those critical moments. That's what directly impacts MTTD and MTTR, particularly in those isolated or air-gapped networks where latency would be even worse or impossible.
And for the folks listening who live under the constant pressure of audits and governance frameworks, this stack seems almost purpose-built to generate the artifacts they need. It looks like it provides controls that map directly to things like ISO 2701, the NIST cybersecurity framework, and it would certainly help with PCI, DSS, IPA compliance efforts too. Beyond just mapping to controls, what about specific security features for governance?
Well, there are several key ones. Things like global PII scrubbing. The system can automatically find and redact personally identifiable information in logs and network requests before they're even stored long-term. That's huge for privacy regulations.
Essential these days.
Definitely. Then there's the mandatory use of immutable audit logs we talked about. Every action is recorded and can't be tampered with. Plus, integrated SBOM software bill of materials and checksum verification for all its own software components. So you have assurance about the integrity of the security platform itself. And it all culminates in producing what they call evidence-grade reporting. The system is designed to guarantee that those final outputs, the summary final.pdf, the final chain bundle.zip containing all the artifacts, are effectively sealed. They include time zone info, the host context, digital signatures, checksums.
So it's court ready, basically.
That's the goal. Undeniable, legally soundproof of what happened and what actions were taken. That's something Cloud-First Solutions often struggled to deliver with the same level of certainty, especially in highly regulated or offline environments.
Okay, so let's step back, look at the wider market. What really makes this RansomEye approach strategically different from, say, more traditional EDR, XDR solutions?
It feels like it's carving out a specific critical niche. The market is absolutely flooded with cloud-first, subscription-based security tools, right? XDR, EDR, SIEM, SOAR, mostly cloud-dependent. RansomEye seems to be deliberately going against that grain. It stands out because of that combination. The full air-gapped functionality across every single module, the native local LLM doing summarization and analysis offline, the native SHA explainability on every decision, not just some,
Then the licensing model too.
and the support for perpetual on-prem licensing. That's a huge difference from the mandatory subscription treadmill of most cloud services. They're clearly targeting a market segment, critical infrastructure, government, defense, sensitive manufacturing that prioritizes control, long-term cost predictability, and absolute auditability over maybe the elasticity of the cloud. It's a different philosophy. Hashtag tag outro.
Okay, let's try and summarize the key takeaways from this deep dive then. RansomEye aims for a genuinely unified defense, covering the whole life cycle from initial detection right through to DFIR and recovery. It ensures local control, which is paramount for its target audience, through things like that rootless agent design, relying solely on PostgreSQL and offering perpetual licenses. And maybe most importantly, it provides audit-ready and critically explainable AI. That SHAP component seems central.
Yeah, I think the emergence of platforms demanding local processing, mandatory explainability like SHAP, and immutable evidence.
Yeah.
It really raises the bar, especially for security vendors serving critical infrastructure. So maybe a final thought for you, the listener, to chew on. If every single security decision your systems make, from linking two seemingly unrelated events to deciding to automatically isolate a host, could be instantly explained with quantitative rationale, with cited evidence, how does that fundamentally change things? How does that change the cost, the legal burden, and maybe even just the speed and confidence of your recovery during the next major incident you face? That level of accountability is, I think, where the industry needs to head.
That is definitely the key question: accountability and automated defense. Something to think about until our next deep dive. Thanks for joining us.